Today we are going to derive this trigonometric identity. Specifically, it's a Pythagorean identity. In order to understand this, you're going to have to understand Pythagorean Theorem, sine and cosine, and polar coordinates. If you're not familiar with those three topics, I recommend you go watch my videos on those. Otherwise, you can try and see if this makes sense to you. So what we're going to do is we're going to start off by just drawing a circle. It can pretty much be any circle. It doesn't have to be a unit circle. But in fact, I'm going to just label this 0, comma r, just to make that point, and this would be r, comma 0, right? So it's pretty much any circle with a radius of r, right? And so what I'm going to do is I'm going to make another radius at the center and draw it here to this point on the circle, and I'm going to drop a height, right? And I'm going to make sure that this is a right angle with the x-axis, right? And since this is a radius, I'm going to label that r, right? So we have a right triangle, and this base is a horizontal distance, so we call that x, right? And this height is a vertical distance, so we call that y. Vertical is up and down, horizontal is left and right. So voila, we have a right triangle, hence x squared plus y squared equals r squared. That's Pythagorean theorem. So this equation is taken care of. That's where that comes from, this triangle, right? So what about these two? So we have to label this angle right here theta, right? So then we're going to take the cosine of theta. So cosine is the adjacent side over the hypotenuse side, right? So cosine of theta in this triangle is equal to x over r, right? So if I solve this equation for x, I multiply the r over, and I get this equation, x equals r cosine theta. So these two equations are the same. That's where this equation comes from, this one, which comes from this triangle. So now I take the sine of this angle, sine of theta. Well, sine is opposite side over hypotenuse. So the opposite side is going to be the y over the hypotenuse, which is going to be r. So we have sine theta equals y over r. And if I solve this for y, by multiplying the r over, I get what? I get this equation. So this equation comes from this guy, which comes from this triangle, right? So all of these equations, now you understand where these equations come from, okay? So now you want to see that this equation here looks remarkably similar to this equation here. That's not a coincidence. These are squared, these are squared. The only difference is there's no square here, but you could actually put a 1 squared there and it'd still be 1. So these look very similar. So why is that? So what you're going to do is, this is x and this is x. Well, x equals r cosine theta. So couldn't we replace this x with r cosine theta? Yes, we could, because that's what it's equal to, right? So we're going to replace that with quantity r cosine theta, right? And we square that, plus, then we're going to do the same thing with y. So here, y equals r sine theta, so we're going to replace or substitute this y with r sine theta. So quantity r sine theta squared equals r squared, right? So this equation is the same as this equation. We just plug these into here to get this equation now, right? So we got to distribute the square to everybody. So we get r squared cosine squared theta plus r squared sine squared theta equals r squared, right? Notice how there's r squareds here, here, and here. So all we have to do is just divide everybody by r squared, and what are we left with? These cancel out. We get cosine squared theta plus, these cancel out, sine squared theta equals, what's r squared divided by r squared is 1. So voila, that is where this trigonometric identity comes from. It comes from these equations from a given circle with a right triangle inside that circle. Again, it doesn't have to be the unit circle, okay? It could be any radius, right? It could be 1, it could be 2, it could be 3, it doesn't matter, right? So that's where this equation comes from. Hopefully you're able to follow that. If so, good job. My next video, I'm going to talk about the other two trig identities, the other two Pythagorean identities that go along with this one. So if this video was helpful, please like it, subscribe to my channel, and thank you for watching.